Hello guys, welcome to this lesson. So in this lesson today we want to look at scientific notation. Scientific notation also means standard form. Another name for scientific notation is standard form. Okay. So I'm just going to write it. So scientific notation also means standard form. Standard form. So you must still remember this maybe from GS2 or GS3 where it was taught. Okay. So it is normally taught after indices, and it is very important if you want to work with natural logarithm. In fact, it is very important in every aspect of science. Use it in chemistry, use it in physics to calculate large or small values. So basically, a number is said to be in standard form if you can write the number as 8 times 10 raised to power n. Okay, any number that you can write in the form 8 times 10 raised to power n is said to be in standard form. Okay, so this a is a number. This a is a number between 1 and 10. Okay, that is a is greater than or equals to 1 and strictly less than 10. So a can take values from 1 to 9.99999, but a cannot be 10. Okay, a cannot be equal to 10 and above. A cannot take values from 10 and above, but we can have values from 1 to 9.9999. Now you can see that a is greater than or equal to, so any number greater than or equal to 1 must begin from 1 or 1 point something. So a cannot be equal to 0, and a cannot take negative values that are less than 1. Okay, so a cannot be 0 point, a cannot be minus 1 point, so it is not a standard form. So that is why we say strictly from 1 to 9.999 something. Okay, so that is what it means. And the n are both they are both positive and negative whole numbers. N are both positive and negative whole numbers. Okay, positive and negative whole numbers. You know, whole numbers are also integers number, right? They are integers, so n can be positive or negative. That means n can be any value. Okay, n can be 10 raised to power n can be equal to minus 1 up to minus the something. N can also be positive, but it must be whole number. Whole numbers are integer numbers, number without decimal point. Okay, so whole number, if it is equal to 0, of course you know that it is equal to 1. So 10 raised to power 0 equals to 1. So that is what it means. And 10 raised to power 1 equals to 10. So 10 raised to power 2 equals to 100. So this is what we call a standard form, guys. So hope you understand the logic behind it. That is how you can define standard form and the usage. So we're going to take some examples now, and then you see how to express numbers in standard form. This is just a recap from yesterday. Okay, so scientific notation of standard form involves writing any given number between 1 and 10 multiplied by a power of 10, that is a times 10 raised to power n, where a is greater than or equal to 1 and strictly less than 10, and n is an integer. So we are going to be looking at the following example briefly. Okay, so please make sure you follow along, get your pen and your paper and walk along. Express the following quantities using scientific notation. Remember, wherever we mention scientific notation, we mean standard form. Okay, scientific notation is standard form, just that the general name for it in physics, chemistry, and other sciences like biology is scientific notation. They don't normally call it standard form. It is in mathematics that we call it standard form. Okay, so alright, express the following quantities in standard form. A. There are approximately 4 million red blood cells in a drop of blood. So we're going to write it out first, and then we write it in standard form. You know that million, okay, when we say million, that should be how many zeros? 6. And then if we write this 4 million in standard form, we have 4 times 10 raised to the power 6, and that is the answer. Okay. B, the thickness of a coin is about 0.008 meter. So we write out what we have, 0.008 in standard form. Of course, you know that here you are counting from the back, but you know that 0.008 is the same thing as 8 over 10,000, right? Which is 8 times 1 over 10,000. So 10,000 is equal to what? 10,000 is equal to uh, 10 raised to power 4, right? So that would be 1 over 10 raised to power 4, which is the same thing as, if you apply the negative index law, that would be 8 times 10 raised to power minus 4. Okay, so that is that. So know that, remember that 1 over a is the same thing as a raised to power minus 1, and that, so if you don't want to go this long step, all you just need is to count the number of zero you have, both the one before decimal and after decimal, that is 4, and then you write the number times 10 raised to power minus 4. So the power of 10 is negative when your number is less than 1. Again, the power of 10 is negative when the number given is less than 1. And remember that your first number, the number you are multiplying by the power of 10, must be greater than or equal to 1 and greatly less than 10. So 8 is between 1 and 10. So that is the right answer. Alright, let's go to activity 2. Express the following. Express the following quantities as ordinary decimal numbers. So we can change from scientific notation to ordinary numbers in the way we also change from ordinary number to scientific notation. So let's see these examples. The sun has a diameter of 1.392 times 10 raised to the power 6 kilometer. Okay, so all we are going to do is to multiply this number by that. So that would be 1.392, 10 raised to the power 6 is 1 million, right? Kilometer. And then we multiply. So when you cancel zeros, 1 2 3, decimal point move forward, 1 2 3. Okay, and that will be 1392 multiplied by 1000, multiplied by 1000 kilometers, and that will be 1,392,000 kilometers. So this is how you can change from standard form to ordinary form. You use a simple multiplication. Okay, so let's look at B. A piece of paper of about 1.8 times 10 raised to the power minus 2 centimeter. So the thickness is 1.8 times 10 raised to the power minus 2 centimeter, right? So we'll break it down into 1.8 times 1 over 10 raised to the power 2 centimeters. So you will use the negative index, bring down the power, that will be 1.8 times 1 over 100 centimeter, which is 1.8 divided by 100 centimeter. And then when you are dividing by power of 0, decimal point move backward. So decimal is here, and that will be 0. So that is 0.018 centimeters as the answer. So this is how you change from standard form to ordinary form, guys. Hope you are following. Take C, pause the video and take C as your classwork. Okay, so welcome back. So your answer should be equal to 332 million, right? 32 million. Okay, and you mark it and give yourself 2 marks. Activity 3. Simplify the following products, writing your answers in scientific notation. Simplify the following products, writing your answers in scientific notation. So let's look at A. 3 times 10 raised to power 3 multiplied by 4 times 10 raised to power 7. When you are dealing with a standard form, we can also collect like terms. Okay, so if you collect like terms here, we have 3 times 4 times 10 raised to power 3 times 10 raised to power 7. So 3 times 4 is 12. Use the law of indices here. 3 plus 7, that will be 10. 10 raised to power 10. So if you can see, this final answer is not in standard form, so it is not our final answer yet. Okay, so we have to change to standard form to give the answer in final answer. 12 is bigger than 10, so your standard form cannot be the number cannot be greater than 10. So we do 1.2 times 10 times 10 raised to power 10, and then this is 10 raised to power 1, 1 plus 10, that will be 1.2 times 10 raised to power 11, and that is the answer. Okay, so example, let's take one more example, then you do the remaining as class. So I've taken this one, let's take this one. C, 8 times 10 raised to power minus 4 times 7 times 10 raised to power minus 5. So this will be 8 times 7 times 10 raised to power minus 4 times 10 raised to power minus 5. So 8 times 7, that will be what? 56, good. So 56 times 10 raised to power minus 4 plus minus 5, that will be minus 9, okay? Then 56 is greater than 10, we make it less than 10, that's 5.6 times 10 times 10 raised to power minus 9. So this is 1, and this will be 10 raised to power 1 plus minus 9, that's 10 raised to power 1 minus 9. So that will be, there's decimal point here, so that will be 5.6 times 10 raised to power minus 8, and that is the final answer. So you pause the video and take B and D as your classwork. Alright, so let's check your answer. So if you add the power here, that's 3 plus 5, that is 8. 4 times 7 is 4 times 7 is what? 4 times 7 is 28. So this will be 2.8 times 10 raised to power 9. Is that what you got? Good. So 9 times 6 is 54, and minus 5 plus minus 2, that's minus 7. So 5.4 times 10 times 10 raised to power minus 7, that will be 5.4 times 10 raised to power minus 6. So that's what you get. Mark it, and give yourself 4 marks, 2 marks each.